what is the spectral characteristic or spectral signature of the waste, and what is before it is treated, and how we could differentiate, not by seeing the turbidity or not by doing any gravimetric method, but rather we would like to check online by seeing their spectral characteristics. So it is a non-destructive online kind of a water surveillance systems. How your wastewater treatment plant is efficiently working, or how much the waste that you have, how much efficiently your cleaning is being done.
Okay. Yes. Thank you.
Yeah. Please explain how you're working.
Yes, so this is a small wastewater treatment plant, a mini wastewater treatment plant. So these 3 reactors are running in triplicate, so they're not connected in any way to each other. And what's happening here is I'm using activated sludge. I've seeded activated sludge from the East Lansing wastewater treatment plant into each one of these reactors. Inside each of these is an aeration stone connected to one of the pumps on the other side. Air is pumping through this continuously, and I measure dissolved oxygen every day just to make sure they're getting between 6 and 7 milligrams per liter consistently. In this aeration tank, again, is the activated sludge, and the wastewater is pumping in the top over here. So right now we're working with a 16-hour hydraulic retention time, so the amount of time that the sewage sits inside this aeration chamber. From there, the overflow drips down into these tanks at the bottom. These are settling tanks. And I collect effluent from the top, and the extra sludge settles to the bottom and is then recycled every day.
So this is continuous process, not a batch type. It's continuously you are working on that. And activated this sludge.
This right now is the sewage.
Okay.
The activated sludge sits and lives in here. Yeah.
So what exactly there in activated sludge? Do you know any chemicals or materials that you're using?
So the activated sludge, we're not adding anything to it. It's directly from the East Lansing wastewater treatment plant. So it's their conglomeration of bacteria, fungi, and viruses that they've harvested or brought up over time. And it seems we're looking at the differences in gene sequencing as we change the hydraulic retention time, the amount of time the sewage sits inside the aeration tanks. Yeah.
Okay, so now but what you have done, we are not doing. What we have done, you are not doing. So it is like a complementarity, a kind of scenario. What we are trying to do is, well, you are doing this one, and how much efficiently this activated sludge has cleaned this wastewater. How do you assess that? How do you monitor that?
So I monitor it twofold. The first way is COD. So I measure COD going in the sewage going in, and then I measure the COD in the effluent. Additionally, I'm working with Dr. Joan Rose over in Natural Resources and doing colophage work with her. So I work with those indicator viruses that infect E. coli, and I look at how much the concentration of the phage going in the form of sewage, and then how much is coming out. Yep.
So now the thing is that have you ever thought like these systems is once put in place works continuously, and it could treat the wastewater the way it has been desired, and how do you assess that kind of certainty that this waste treatment plant is perfectly functioning? So like for instance, you say the COD, POD you are measuring, right? And besides that, have you measured like a TS and TSS?
I do measure TSS. I
measure TS and TSS.
But TSS I only measure to establish stability inside my aeration chamber, which is just to make sure that there is a stable amount of that activated sludge inside that aeration chamber. I use primary sewage or sewage after primary settling to feed, so there aren't that many solids in the sewage. And then when it comes out in the effluent, there again isn't much. There aren't many solids, but I do use NTU, turbidity.
Okay.
Yes.
So when we say TS, TSS, of course DS also, dissolved solid particle.
Okay. I'm not measuring dissolved solids.
Okay.
Yeah.
Because these are the three major things, because turbidity is a very visible, but TS you can't see.
No.
It's already dissolved. TSS, this is suspended solid particle. Also, you could see as a matter of fact like a turbidity you can see. But TS.
You do measure turbidity.
I do measure turbidity.
Yeah.
How do you
Yes.
measure turbidity?
So I actually have a turbidity meter.
Okay.
Yes.
So you take a sample and you do some gravimetric analysis.
Yes.
Okay. This is a process that you have been doing, and this is like a batch type. You don't do continuously monitor.
I monitor once every day for the sewage and the effluent.
So with this system, what we are trying to do with the spectral analysis system is that we will create a library of the spectral signature of the wastewater
Okay.
before treatment and after treatment, and we will have the gravimetric analysis also in place, so that the spectral analysis, the spectral data that we get, it correlates with your gravimetric method, because we know for sure, because the gravimetric method is a very much reliable, and you could exactly come up with the TS and TSS. So what we'll try to do a little bit automate the system by introducing these NIR sensors, where we try to get the NIR spectral data correlates with your gravimetric analysis, and we make those as a teacher signal, the signals that is a non-parameters. We do that one, and later on what we'll do with the all non-parameters, with this established spectral signature, we try to analyze once the wastewater is coming out, once the treated water is coming out, how much the TS and TSS is contained there by analyzing their spectral characters.
Okay. So
This is a part that we are trying to work.
establishing the correlation.
Yes.
Okay.
We will establish your gravimetric analysis result with a spectral character, because Dr. Suzy and Dr. Professor Kathmandu, they are working on getting the spectral signature of this wastewater that has a certain amount of TS or TSS that you have measured in
Yes.
this one. So we correlate that one, and later on we put on water, and we try to see where exactly it matches, and try to see, okay, this has this much TSS, this has this much TSS. So we'll rate the
Okay.
water based on the spectral signature that we get, and that will be that you said one time you do. This will be continuously we could monitor. It will be like anytime once the spectral signature is getting there, we could have a continuous monitoring systems on a screen, and you could see, this time the TS is high or TS is low, or this TS has gone this level. Continuously you can have monitoring rather than batch time. Continuous monitoring. This is where we are trying to work.
Okay.
Yeah.
Okay.
Yeah.
And so, application-wise,
Yeah.
is this something that you're trying to
Exactly.
apply?
The application in our part, because of course in US you have very well stepped. We saw yesterday in East Lansing, the wastewater treatment tank and all. You do very efficient. But in our part, in Asia, I can say, especially South Asia, or even in Thailand, what we do is normally the waste from the industry or from the hospital, they are treated. Some are doing treatment and some are not. And they will just dispose those water into the river systems, and the rivers get polluted. Of course, having done this type of continuous monitoring, what we can do is someone who really are sincere about treating their wastewater before it gets discharged into that, they will get honor, or they will get rewarded. But someone who is not doing that kind of things, some hospital or some say factory, some industrial setups, if they are not treating their water and simply disposing to a groundwater or simply disposing to river system, either they will be warned, they will be given an information, they will be given flag, your water is this time.
Okay.
So if you do a batch time, one time you sample collection, what happened?
You
You
might
take
not
it, you
catch.
might not catch
Okay.
24 hours,
Yes.
because you may give a best sample. You may take a best sample, because what you are doing, honestly and frankly speaking, in our part of the world, we need to be a little bit careful on that sense, because you may take the best sample and you take a good result and you say, see, my water I have treated perfectly.
Yes.
This water that is we're disposing in a groundwater system or in a river system is perfect. See the result. But if we have a continuously monitoring system throughout the time, then we go, hey, see, from 6 a.m. to 9 p.m. you are doing perfect, but from 9 p.m. you open the bulb and you
let everything
let
out.
everything out.
Yeah. Okay.
So
Yes.
this can have we will have a wastewater treatment surveillance systems installed in a place, so that the polluters will be penalized, and the person who cleans the water will be rewarded.
Okay.
So I think you understand why we need this kind of enforcement system. By the way, your system is, we are not trying to replace your gravimetric system. Your system is perfectly fine. There's scientifically, it's a well proven how you measure TS and TSS. It's perfect. But there's a chance, a loophole for people who wants to make
In the system,
yeah.
Okay.
You get it.
Thank you for the explanation. Yeah. I'd be happy to help.
Yeah, so that way, we will see, because we really want this wastewater treatment plant is placed all over the world, because we are working in the global health systems, because a lot of US people are traveling to Asia, go to Thailand, go to Nepal, or go to China, or all these things. We want to make sure that the water that we drink or the water that we make use of there is safe for all the people.
Yes.
It's not like if the water is only safe in the US and a lot of 50% of US people are traveling outside, when they come back they will bring a disease.
Yes.
So we need to work clearly, not only cleaning here, cleaning all over the world. So you have developed a perfect system, but these systems need to be installed in such a way that it works. At the same time, it serves the purpose where people will have a minimum chances of manipulating the system.
Yes. Fine. Okay. Well, finding loopholes. That would
Yeah.
be
Yeah.
That's very
Yeah.
interesting.
Yeah.
The application. I guess I
application.
never thought of it that
Yeah.
way. You can have
Yeah.
you can take a very good sample in the morning, and
Yeah.
then when nobody's looking
Yeah,
is when
just
you
wander
dispose
around.
of
Just
everything
open.
that might be a problem.
Yeah.
So I can see how and why
Yeah.
this would be used. Yeah.
So that way, because everything, nobody is, in fact, nobody is any foul game, but data-wise, it's perfect. Your waste is coming. You have a lab report, certified lab report, but the problem is not being solved because the wastewater is not treated and your river is getting polluted. It's not solved. Where is the loophole lies? They're opening.
And with this system, you would know
Yeah.
exactly where the problem is.
Thank you. Yeah.